Hello, my name is Steve Langevich, and in this video we'll be talking about DHCP, also known as the Dynamic Host Configuration Protocol. This service allows a server to automatically assign IP addresses to clients who are trying to access the network, and it's used in networks from large enterprises to your home router. We'll start out by taking a look at my network I built for IT130, and in this configuration on server 2, I have also applied a DHCP route. We'll start out by taking a look at my network map that I made for IT130. Looking in VLAN 10, the innermost network, I have server 2, which serves as a domain controller, a DNS server, as well as the DHCP server on the network. This DHCP server also services VLAN 5 in the network separated by this router. Now we'll jump over to my server and we'll take a look at DHCP in action. And we'll do this by capturing traffic packets on server 2. And we'll do this with workstation 1. What we're going to do is release the IP configuration and renew it, which will force the system to request a new IP address from the DHCP server. So that command releases the IP configuration, and then we'll run ipconfig renew. And we'll jump over to server 2 and see what we can find. So right now it's running and capturing all data packets going across the network. We'll apply a filter here that searches for DHCP in the header. And what we have here is 4 transactions. Altogether they're called DORA, and they stand for discover, offer, request, and acknowledge. So first up is discover, and this is coming from the client, in this case workstation 1, and it's sending a broadcast out on the network looking for any DHCP servers that would be able to help. The next is offer, and as we can see, this comes from server 2, the DHCP service, and this is a response to the client that also has configuration options that the client can use. DNS server location, the domain the DNS is in, as well as the IP address and subnet mask. The third transaction is a request transaction, which comes from the client to the server, and basically this validates what the server sent out, kind of verifying all the information it received is what the server originally sent out. And the final transaction is acknowledge, again coming from the DHCP server to the client, and this is a confirmation that this workstation now has the IP address that it discussed with in the previous transactions, and kind of says this is where you're at, this is where we see you at, and that wraps up the exchange, the handshake. Now that we're in server 2, we're going to go take a look at the settings for DHCP. We can see this is in the Nishnaabemowin domain. As we can see, there's 2 scopes on the server, one for VLAN 5 and another for VLAN 10. And a scope is basically a listing of IP ranges that can be applied to a client that's looking for an IP address, as well as some other settings included. So if we look further into VLAN 5 scope, we can see there's a address pool, and this ranges from the IPv4 address of 192.168.5.1 to 192.168.5.254. And then the last, beyond that, is 255. That address is reserved for the broadcast domain for this subnet. We also see there's an exclusion list, and this is the range of 192.168.5.1 to 192.168.5.3. This is set aside for the gateway of 192.168.5.1, server 1's address, which ends in .2, and a network connection to DNSE1, which is on the .3 network. We also have another exclusion of 192.168.5.20 that in this particular configuration is another gateway going into the VLAN 10 network. It's on Gigabit Ethernet 1 on the router VM130-2. Looking in here, we can see some scope options, and in this particular setup we have the router's gateway address, and that's the 192.168.5.1 address. We also have a DNS server set up. That way when the client gets this DHCP information, it'll know the gateway and it'll know where to go for name resolution. And this address is 192.168.5.2, which is the same as server 1. That's because that's also a read-only domain controller with DNS, so it can locally resolve names for the clients as well. On the last value, we have the DNS domain name, which in this case is the anishinabimoan.com domain. If we right-click and go to Configure Options, we can see we can add a lot of other resources, a lot of other options. And these are all applicable to different situations, but in our basic setup here, I just have the 3 set up. And looking in the scope for VLAN 10, we have a similar address pool with ranges available for distribution, as well as IP addresses that are excluded from distribution, which include the gateway for VLAN 10 and the server address in VLAN 10. And looking under the options, we have similar options as VLAN 5, just with different addresses fitting the network. Now, because the DHCP server is located in one subnet, any clients that try to join in VLAN 5 are going to have issues trying to reach VLAN 10. Because our DHCP server is located in a different subnet, any client that tries to join on VLAN 5 is going to have trouble trying to communicate with that server. This is because, well, they're separated by a router here, and routers separate broadcast domains. Now, because the DHCP handshake occurs on a broadcast domain, it's not going to easily travel through when there's a router blocking the way. What we can do, however, is add a relay agent. And what this does is carries the DHCP request across the broadcast domain boundaries. In this instance, I set one up on Gigabit Ethernet 1, and for Cisco, it's going to be a IP helper command. We'll jump back over into our server and take a look at this. Pulling up the configuration of router VM130-2, we can see 4th line down there is a command IP helper address, and it lists the address of the DHCP server. Now this is on Gigabit Ethernet 1 because this is the leg that goes into VLAN 5. So if I added a client here, it's going to send out a broadcast address, and it's going to go and it's going to hit the router on the Gigabit Ethernet 1 side. Now because we have that command applied to the Gigabit Ethernet 1, it's going to automatically carry that DHCP request over the router and therefore into 192.168.10.2, which is our DHCP server. Relay agents can also be in Windows Server as well as some firewalls. Basically any device that can separate two broadcast domains or separate two different subnets. Now, to provide redundancy in case one of our DHCP servers fail, we can apply a couple different options. One is called split scope, and this is running two or more servers and with equally splitting the DHCP scopes. So in our example, if we applied this process to my server, what we would do is take VLAN 5 and broadcast half the addresses onto one server and have the other half of the addresses on a second server. This way, in case one server fails, the other will have addresses it can lend out and continue to service the clients that connect. Another option is called clustering. This is a format that's used on Windows 2000 servers. Basically, it has two servers running together that share a common storage, data storage, and they basically operate as one server. They split the load equally and distribute DHCP addresses equally. And that way, if one of those servers fails in the cluster, the other will pick up and continue to service the clients. And the last option is called failover. It's a newer feature as of Windows 2012. And what you do is configure two servers. You can have them run as a hot standby mode or what's called as load balancing. So on hot standby, basically you have a server running that has all the DHCP lease, that has all the IP lease data, and it's replicated on both servers. So if one goes down, the other can quickly pick up and replace it. The other is called load balanced, which basically both servers distribute IP addresses, and they both track each other's changes. So that way, if one goes down, the other can continue without any hesitation. One issue that networks can face is having rogue DHCP servers come online. Basically what happens is a server connects to the network. It's given an address through DHCP, but this server also has a DHCP service running on its own. So once it's connected to the network, any client that requests a IP address, both the authorized server and the unauthorized server, the rogue server, can both respond to these queries. It can cause network delays, and clients can potentially connect to malicious servers, which can lead to a breach of data or possible infection of viruses. Best practices that should be used with configuring a DHCP system is to deploy more than one DHCP server to improve reliability. That way, if one server goes down, the other can take its place and continue to provide services to the clients that connect. Also, the use of a superscope is recommended by Microsoft if two or more DHCP servers are used. A superscope combines two or more regular scopes, which allow it to be easily accessed between the multiple servers and easily share information about them between every server. Lastly, it's recommended to apply reservations on all applicable servers, meaning if a client needs a certain IP address and it's set up through a reservation on one server, that same reservation should be made on all servers. Reason being, if the main DHCP server goes down and another one takes its place, it may unintentionally give that reservation out to another client. So if all reservations are on all servers, no mistakes can be made. That concludes our brief discussion of DHCP. I hope you enjoyed.